Ever wondered how your computer remembers things even after it's turned off? Well, that's the magic of read-only memory, or ROM. This non-volatile memory is the guardian of your digital electronics and computer systems, ensuring that essential data remains intact even when the power is off. Unlike its cousin, the random access memory, or RAM, which forgets everything when the power is cut, ROM retains its memory. It's like the elephant of the computer world, never forgetting. From firmware to software, ROM carries the crucial programs and data that your devices need to function properly. But not all ROMs are created equal. There are different types, each with its unique characteristics and use cases. Intrigued? Good. Now let's dive into the different types of ROM and understand their unique characteristics. First on the list is mask ROM, also known as MROM. This type of read-only memory is a bit of a throwback in the digital world. It's as permanent as it gets in the realm of digital storage. You see, the data is encoded, or in more technical terms, masked onto the ROM chip during the manufacturing process. It's a bit like carving your initials into a tree. Once it's there for good. No changes, no updates, no do-overs. What's written in MROM stays in MROM. Now you might be wondering, where would we use such a permanent type of memory? Well, you'd be surprised. MROM is actually perfect for applications where the data doesn't need to be modified or updated. Think about the BIOS in your computer, or the firmware in your gaming console. These are foundational programs that kickstart your devices and generally remain unchanged throughout the lifespan of the device. But MROM isn't just about providing a stable foundation for your electronics. It's also about cost effectiveness. Because the data is embedded during manufacturing, MROM chips are cheaper to produce in large quantities, making them a cost-effective solution for mass-produced devices. So while MROM might sound like a relic of the past, it's still a crucial component in our modern digital world. It's the steadfast, reliable type of memory that gives your devices a place to start from every single time you power them on. So MROM is ideal for applications where the data doesn't need to be modified or updated. Next, we have programmable ROM or PROM. As the name suggests, this type of ROM can be programmed by the user after it has been manufactured. But you might wonder, how does it work? Well, when a PROM chip is manufactured, it initially contains all ones. It's like a blank slate, ready to be filled with information. Now the user can program specific bits to zero using a special device called a PROM programmer. This process of programming is also often referred to as burning. The catch here is, once a bit has been programmed to zero, it cannot be changed back to one. That means the data is fixed and cannot be altered. It's like writing a sentence with a pen on paper. Once written, it cannot be erased. Now let's talk about where PROM might come in handy. If you're working on a small-scale production or prototyping project where customization is crucial, PROM is your go-to. It allows you to program the ROM with the specific instructions or data required for your project. However, keep in mind that if the data or instructions need to be updated or changed, you would need to replace the entire PROM chip. Despite this limitation, PROM offers a cost-effective solution for projects that require a one-time programming of data that doesn't need subsequent alterations. PROM is suitable for small-scale production or prototyping where customization is needed. Moving on, let's talk about erasable programmable ROM or EEPROM. This is a unique type of ROM that has the ability to be erased and reprogrammed. But how exactly does this work? Well, it's quite fascinating. EEPROMs are designed with a small quartz window on top. This isn't just for aesthetics, it serves a very specific purpose. This window allows ultraviolet or UV light to reach the memory cells within. When you expose the EEPROM to UV light for a certain duration, the stored data is erased. That's right, you can clear the memory of an EEPROM with light. This is a far cry from the permanence of mask ROM and the one-time programming of PROM. But why would we need such a feature? Well, consider a scenario where the data stored on a ROM needs to be updated or changed occasionally. With mask ROM or PROM, you'd need to replace the whole chip, a process which is both cost and time-intensive. But with an EEPROM, you simply erase the existing data with UV light and then reprogram it with the new data. It's important to note that this isn't a fast process. Erasing an EEPROM can take up to 20 minutes, depending on the intensity of the UV light and the size of the chip. And reprogramming it isn't exactly speedy either. But in situations where you need the flexibility of occasional updates, the EEPROM is a solid choice. So what are some use cases for EEPROM? They're often found in devices like video game consoles, where game data can be updated without needing to replace the whole chip. Additionally, they're used in industrial applications, where machinery or equipment firmware may need periodic updates. In summary, EPROMs offer a unique blend of flexibility and stability. They're erasable and reprogrammable, but they still retain the data integrity and permanence we expect from ROM. It's a perfect balance for certain applications and a testament to the ingenuity of computer memory design. EPROM is useful for applications where occasional updates to the stored data are needed. Next up is electrically erasable programmable ROM, better known as EPROM. This is a unique type of ROM that shines in its ability to be reprogrammed electrically. EPROM stands out from the rest as it does not require ultraviolet light to erase and rewrite data, making it considerably more flexible and user-friendly. EPROM is a form of non-volatile memory that can be erased and reprogrammed byte by byte. This ability to rewrite individual bytes is a significant advantage, as it allows for precise and targeted modifications. This high level of control over the stored data is a remarkable feature of EPROM and sets it apart from other types of ROM. Moreover, EPROM can undergo multiple write cycles, meaning it can be erased and reprogrammed repeatedly. This reprogrammability makes EPROM a versatile option for storing data that may need to be updated or changed over time. So, where does EPROM come into play? Well, it's particularly suitable for applications where frequent changes to the stored data are necessary. Imagine a system that needs to keep track of certain parameters that are subject to change, like system configurations or user preferences. EPROM would be the ideal choice in such scenarios due to its ability to adapt and update the stored data as required. However, it's worth noting that EPROM typically has a limited number of write cycles. This means that the memory cells in an EPROM chip can only be erased and reprogrammed a certain number of times before they start to degrade. This limitation, while significant, is usually not a problem in most applications, as the number of write cycles is typically in the hundreds of thousands. In a nutshell, EPROM brings flexibility and adaptability to the table. It allows for targeted and frequent changes to the stored data, making it a versatile and user-friendly type of ROM. While it does have its limitations, EPROM's benefits often outweigh these, making it a popular choice for many applications. EPROM is suitable for applications where frequent changes to the stored data are needed. Finally, we have flash memory. This is a type of electrically erasable programmable read-only memory, or EPROM, that can be erased and reprogrammed in blocks, not just byte by byte. This block-based approach makes flash memory more efficient than traditional EPROM when dealing with large-scale operations. Flash memory is divided into blocks or sectors, each of which can be erased and reprogrammed. This structure allows for a faster and more efficient erasure and reprogramming process, making flash memory an ideal choice for applications that require frequent data updates. Now let's talk about where you typically find flash memory. It's commonly used in USB drives, memory cards, and solid-state drives, or SSDs. These devices require the ability to quickly and efficiently read and write data, and that's where flash memory shines. Beyond these applications, flash memory is also a critical component in many consumer electronics. It's used for data storage, of course, but also for firmware updates. When a device gets a firmware update, it's flash memory that's being reprogrammed with the new instructions. So whether you're saving files to a USB drive, snapping photos on your digital camera, or updating the firmware on your smart TV, you're using flash memory. It's a versatile and efficient type of ROM that plays a crucial role in our digital world. Flash memory is widely used in consumer electronics for data storage and firmware updates. To wrap up, we've explored the different types of ROMs and their unique characteristics. From the permanently encoded mask ROM, the user-programmable PROM, the UV erasable EPROM, to the electrically erasable EEPROM and the efficient flash memory. Each has its unique use cases, from firmware storage and bootstrap code to data security and embedded systems. Remember, the choice of a ROM depends on your specific requirements, including the need for reprogramming, capacity, and cost considerations. Until next time, keep exploring.